What's up, everybody? It's Coach Arf. Welcome back to my Algebra 2 notes and lesson videos. So what we got today is the second part of our first lesson from Unit 1. Again, the new Unit 1 here in 2023, 2024, since they've changed up our curriculum a little bit. So we're in Unit 1, which is statistics. Again, our statistics unit's all about the different ways we can go about collecting data. Again, y'all gotta, I've said it in class, y'all gotta think like almost like we're applying the scientific method. Think like an investigator trying to find out answers to questions, trying to find out the whys, things like that. This first lesson, we're not going quite that deep yet. But we are still implying methods of data collection and analyzing it. So it's all been about probability. If you watch the first video, the first assignment was about coin flips and probability, and we did a virtual coin flip simulator instead of actually flipping coins. So we got a couple more activities here, which are kind of similar in that we're not actually doing what the task is suggesting. We're getting something to replace it, aka a simulation. So let me go ahead and share my screen. You will click, I'm already in Canvas, so get on Canvas, click on your class. I'm clicking on first period. Go to assignments, using simulation to model chance behavior. All the links y'all are going to need, the virtual dice roller and the cereal box problem, which y'all will see in a minute, are right there. Here's the worksheets, and y'all can see I've already got the link for the first video up now. Here's your worksheets. You click on that link. I have it open in another tab, which I'll go ahead and go to. All right. So here's the probability coin toss, which we already did in the first video. Again, if y'all were here in class and went over and you're just, again, kind of going over this as a freshman, making sure you got everything. There was something we did before this about the soda contest, about rolling the dice, what's your probability of getting whatever number when you roll dice. It's kind of incorporated in here anyway, so we'll just kind of skip over that. Our soda contest true. So again, on your paper, where is my? Here it is. So the last question, question 5 from the probability coin flip lesson. There it is. I would draw a page break. Our soda contest true. Again, you can just do it all on one. If y'all have seen me in the last couple days, I do actually now have the paper copies of y'all's assignments. So, if we won't have to worry about writing it on our paper for the most part going forward. But I would do our soda contest true. And again, make it big enough where I can tell it's the new lesson and go from there. Talked about in class. Angled that too much. There we go. Talked about in class. I don't feel like I see it as much anymore, but particularly when I was y'all's age, seemed like all the brands kind of alternated who was having a contest, whether just straight up had a message on the soda lid or a code you had to go put in somewhere online. Sugar Water, a beverage company, ran a promo contest for the 20-ounce bottles of soda. Some of the caps said, please try again, while others said, you're a winner. Sugar Water advertised the promotion with the slogan, 1 in 6 wins a prize. Mrs. Gallus' statistics class wonders if the company's claim is true. To find out, all 30 students in the class go to the store and each buys 1 20-ounce bottles of soda. Again, obviously, I'm not necessarily going to ask y'all to do that. Maybe I could have, and y'all could have brought it in the next class period, but, we're not going to ask y'all to do that. There's ways around that. So, 1 in 6 wins a prize, 30 bottles of soda are bought. How many winners would you expect to get out of a class of 30? Would expect to get 5. How did you determine your answer? Well, 1 in 6 wins a prize. There's 30 students. You get a few ways to go about it. 30 times 1 over 6, 30 divided by 6, you kind of look at the real world example I'll talk about in a second, but easiest thing probably to get there would be 30 divided by 6. If we kind of wanted to plot it with a more real world example, 1 in 6 wins a prize. So we need to break up our class into groups of 6. There's 30 students, there would be 5 groups of 6. Within each group of 6, one person will have a cap that says it's a winner, the others will be losers. 1 winner per group, 5 groups, 5 winners. Number 2, of the 30 students who purchased a sugar water soda, only 2 have caps that say, "You're a winner." Does this result give convincing evidence? You have to pay attention to some of these keywords. Convincing evidence that the company's 1 in 6 claim is inaccurate. And we're talking about the 1 in 6 claim. We're talking about, not the 30 bottles of soda that you bought, not the rest of the bottles in the store you bought them at, not the rest of the stores on the street where you bought the soda at, not the rest of the stores in Covington. Every single bottle of soda. Again, substituting brand names in here. Think about Coca-Cola. How many 20-ounce bottles of Coca-Cola do you think are produced every day? Easily in the 6 figures, I would assume, which we mentioned in class. So, that means there's millions of bottles probably that have these bottle caps on them that are going to be part of the promotion. So, if you have 2 million, 3 million, 5 million bottles, whatever it actually is, and you've only bought 30, there's no way that 30 bottles are going to tell us that 1 in 6 is inaccurate. It's way too small of a sample size. Okay. We use the term sample space in the first lesson, but now we're talking about sample size. If there's 5 million bottles produced and we only buy 30, and that's a fraction of a percentage of the total number of bottles. So that's not really enough to tell us anything. So what we're going to put here for number 2, again, wording. If you did get this one in class, wording might be slightly different from the wording I used in your class, but the same basic idea. No, because we have too small of a sample size. Too small of a sample size. Again, pause it if you need to. I don't want to sit here with 30 seconds of wait time every time, make the video too long, so I'm going to go ahead and move on. All right, number 3, plan. What are some ways we can model a 1 out of 6 probability? So dice would probably be the easiest one. I mentioned it a few minutes ago. Rolling a dice, 6 sides on a dice. The odds of you getting any one number are 1 out of 6. We don't even have to write anything for number 3. We just had it as a discussion in class. Trying to kind of incorporate it real world scenario. If you had a spinner wheel, and you have multiple siblings and your parents made like a chore wheel as a spinner wheel, and whatever it landed on, you had to do it. There are 6 different chores on there. Cleaning the bathrooms, sweeping the house, vacuuming the house, cutting the grass, doing the dishes, doing the laundry. The odds of you landing on any one of those would be 1 out of 6. If you went up to someone's house on trick-or-treating and you happen to be the first trick-or-treater, they had a bowl, they bought a 300 count bag of candy and dumped it all in a bowl. And that 300 count bag of candy had exactly 50 pieces of 6 different types of candy. So 50 mini Snickers, 50 mini Twix. Y'all get the idea. So all of at least when you're picking, if you're picking out one piece of candy, there's 50 pieces of candy for all 6 different types of candy. So everything is still equal. So your odds of picking any one piece of candy are 1 out of 6. But, for the sake of it, making everything easy for us, we're going to use a dice. Okay. All right. So number 4, since we are working together as a class, we'll use the 6-sided dice to represent our 1/6 probability. What are the possible outcomes, the sample space, again, different from sample size, for our model? Talked about this with the coin flip. We'll flip the coin, sample space is heads or tails. And roll a dice, our sample space are the 6 sides of the dice. So you need to put 4, A1, B2, C3, D4, E5, F6. 4, A1, B2, C3, D4, E5, F6 is what you need to have on your paper. Since the company claims that 1 in 6 is a winner, again, a little typo, they left something off there. Assign one outcome from the sample space above to be the winning roll. The rest will be the losing rolls, the losers. List them below. Each class have their own different number. So before we pick this, let's actually jump down here just to realize y'all understand what it's not going to matter which number I pick. Doesn't matter if different groups choose different numbers to be winners and losers. What effect come the outcome of the simulation? If we pick the number beforehand, no, it's not going to affect the outcome because of what we just talked about. You have a 1/6 probability of landing on any number. So it doesn't matter which number you pick beforehand. The odds of you landing on that are 1 out of 6. Okay. So what we're doing is we're rolling a dice 30 times to represent us buying 30 bottles of soda. So if we roll a dice 30 times, let's say we said the number 2 is going to be our winning roll. If we rolled the dice 30 times and we only rolled 3 2s out of those 30, but we rolled 8 5s, we can't, after the fact, go back and say, oh, I changed my mind. I don't want 2 to be my winning roll. I want 5 to be my winning roll. So we can't do that. We're not doing that. So before we roll, doesn't matter what number you pick, the odds of you getting that number are 1 out of 6 on any one dice, on any one roll. And the odds of you not winning are 5 out of 6. So I'm going to pick number 6. So you need to write 5A, winners 6, B, losers 1, 2, 3, 4, 5. All right. Moving down to number 6, the actual simulation. Roll your dice 30 individual times to imitate the process of each student in Mrs. Gallus's statistics class buying their sodas. For each roll, record whether the student was a winner or a loser in the frequency table using tally marks. So we don't have to do that. All you're simply going to do is write number 6, trial 1, number of winners, and we'll put it down. You don't have to sit here and keep a tally. If you're rolling one dice individually 30 times, that might help you keep track, but I'm going to show y'all something which is going to simplify it. The reason why I'm showing that is you can maybe roll a die 30 times for this trial. There's 2 more trials down here. So, if you actually wanted to do that at home, maybe you got, 15 minutes or whatever to roll a dice 90 times and record, the numbers that you got, how many winners, how many losers you had. But we're actually going to do 20 total trials down on the next page, which you'll see in a second, which would be 600 individual rolls of the dice. So we're not going to do that. What we do have, let me go back and share the other. Why did that do that? Why did that flip? There. Go back and share the other window. If you click on virtual dice roller, it's going to take you to the link I'm about to show. So you would click on that. It's actually back in this window. You click on virtual dice roller, and it's going to take you to this. Okay. A virtual dice roller. We just have 2. Look what you could do here. You could change the number of dice. So 21. Again, you can just type in 30 if you really wanted to. I'm being a little lazy. 6, 27, 28, 29, 30. 30 die. Try to move this out of the way if I can. I don't want to exit out of anything. There we go. 30 die. I'm going to click roll the dice. So for our first trial, I'm going to click roll the dice. We're going to count how many 6s we got. Okay. We got 1, 2 up top, third one right here, 3 on the bottom. So I count 6. So there's the worksheet here. So for child number 1, you're going to put 6. Okay. Number 7, repeat step 5. Again, that should say step 6. Y'all don't have to write that down on your paper, doesn't matter. 3 more times, but it only has space for 2 trials. So we're just going to do 2 more trials. So for number 7 on your paper, you're going to write down number 7, child number 2, number of winners, child number 3, number of winners. So here we are. Let's move this back out of the way again real quick. Our second trial going to net us, looks like 6 again, looking at it initially. 1, 2, 3, 4, 5, 6. Yes. So 6 more 6s. And again, just talking about if we chose the different numbers, it honestly looks pretty well distributed between every number but 3. There's only 1 3. There's 6 6s, as we said. There's 6 1s. There's 5 2s. Only 4 3s or 4 4s on it. 4 4s. 1 3, 1 2, 3 4 5 6 7 5. So this is actually pretty well split up outside of the lone 3. But we got 6 6s again. So child number 2, you're going to put 6. Child number 3, 1 2 3 4 5. We somehow got 6 again. I mean, we might want to change that. I don't know. We had the number 6 and we got 3 rolls in a row of 6 6 6. I don't. We're gonna go with it though. So you have 7, child 2, number of winners 6, child 3, number of winners 6. Leave the dice roll tab open. Do not close it. You will have to come back to it on your own in a minute. So leave it open. All right. Number 8 is going to be combined with number 9. So you don't have to put a number 8, put the number 9 on your paper. Plot the number of prize winners for each year 3 trials on the dot plot in your classroom. So again, if y'all were here at any point, y'all saw I had it on my board. A dot plot is a graphical display of information. It's similar to a bar graph, but a bar graph has the x-axis and the y-axis. The y-axis is what tells us the quantity, and the bar goes up to that. Instead of doing that here, we're just going to have our possible number of winners. I'm going to stretch it out to 10. You might want to leave a little space on your notebook paper after 10. You'll see why I'm going to say that in a second. But do this. It's just the one axis, the x-axis. We got 6, 6, and 6. So I'm going to put 3 dots above the number 6. So this means 3 trials of 30 bottles. Each of those trials, we got 6 winners. Okay. I'm going to go back to the dice roller. I'm actually going to do one more roll because I just want to see, I want to see us actually get a number that's not 6. All right. So I rolled it. Let me move this out of the way-ish. Got 1 6 up here. And funnily enough, that's actually our only one. Okay. So this is our only 6. So if I go back to my dot plot now, I'm going to put a number 1 above that. And as I do that, I did forget to, I did kind of go over real quick. Let me scroll back up for a second. So talked if the company's 1-6 claim is inaccurate. That's what one of the things that we're trying to prove. And also we got 2 winners the first time that the class did it. We're not actually counting that, but two winners. So we're saying if sugar water is telling the truth, 1 in 6 is a winner. What's the actual probability of getting 2 or fewer winners in a class of 30 purely by chance? So that's what we just did. We ran a trial where we bought 30 bottles. That was our fourth trial of buying 30 bottles of soda, and we only had one winner. Okay. So I'm actually going to do this. I'm actually going to do this for just for the sake of the worksheet, since we're not doing the rest of them. I will go ahead and put that. I didn't do this in class, but that first trial where we had 2 winners, I'm going to put that down as well. Okay. I'm going to tell you why in a second. So now we have 5 trials. Okay. You need 20 total. So this is where you're actually going to have to do a little bit on your own. I'm trying not to make the video too long. All right, I said I'll just give it to y'all. So we'll do this. We'll do this. You know, some of the other videos in the future, y'all gonna have to do it on your own. I already got my 5, so I'm gonna do this. We're gonna roll it 15 more times. I know it might kind of be hard to see the annotation with the black background. So if you can't see where I'm putting the dots, you can wait till after I get done rolling the dots, and you'll be able to see the whole graph. Okay. So I'm gonna do 15 more of these. We're gonna count them up real quick, and I'm gonna put them on. All right. So this roll, again, I only see the one right here. That's the second number 1. All right, 7th roll. We're doing 20 trials, so 20 rolls. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So there's our first 5. What we're expecting to get 5 winners out of every 30 rolls. I think just 4. 2 right here, 2 right here. So 4. Video's already taken longer than I want it to. I need to hurry up. 1, 2, 3, 4, 5, 6. A whole bunch here clustered in the corner and that one up top. That's another 6. My 4th 6. 1, 2, 3, 4, 5, 6, 7. Another 7. How many is that? 2, 6, 7, 8, 9, 10, 11. 11. So we got 9 more. 1, 2, 3, 4, 5, 6. 6 again. Five in the first 2 rows, and I don't see a single one after that. So 5. 1, 2, 3 right there, all touching each other, and that looks like it. It's a good number. There's a lot of 3s. How many 3s are there? 4, 5, 6, 7, 8, 9, 10, 11. That's the highest of any one number I've noticed in any rolls. I haven't counted every single roll every time I've done this, but 11 3s, that's about the most I've seen. All right, so 3 6s. Okay. 2, 3, 4, 5, 6. Another 7. So this is the 16th roll. 1, 2, 3, 4, 5, 7 again. 4 up here in the corner, and that's it. So another 4. One, 2, 3, 3. 1, 2, 3, 4, 5. All right, what's our count now? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 19. All right, last one. 1, 2, 3, and 4. All right. So we have our 20. So here's your dot plot. Again, the height of the dots doesn't matter. You know, ideally, obviously, my bubbles would be the same size, or my dots would be the same size, and you could tell, but the number of dots would matter. So we got 5 dots above 6, 4 dots above 7, 3 dots above 5, 3 above 4, 2 above 3, 1 above 2, 2 above 1. Okay. So again, pause the video if you want to get that down because I'm moving on. What are the total number of trials run by the entire class? So 20 trials, 20 total dots. Again, representing 600 bottles of soda bought, 30 bottles per trial. So 30 bottles per dot times 20 dots. Again, pause this so you can get it down because I'm about to erase it. You just keep in mind these 2 1s and this 2. Keep that in mind as I erase it. Okay. Actually, let me see if I can do something. Keep it on screen for another minute. Sorry, I was gonna see if it would let me move the whole thing up, which I don't think it's gonna do. All right. Okay, so should have your dot plot, 20 trials. So we had 3 trials out of 20. What percent of the time did Mrs. Gauss' statistics class get 2 or fewer prizes? 3 out of 20. So 2 times we only got 1 winner, 1 time we got 2 winners. So we had 3 total trials out of 20. So 3 over 20 is our fraction. Convert it to a decimal. And most of the classes, it just happened to turn out this was 2 over 20, which simplified to 1 over 10, which made these 2 questions easy. This one, we have to do it. Might have to go about it, actually doing a little bit of math here. If you don't know off the top of your head, you might have to actually divide this in your calculator. 3 divided by 20, which is going to be 0.15. 3 divided by 20, which is 0.15. To convert that to a percentage, move the decimal 2 spots to the right, which would be 15%. So 15% of the time, we're going to get 2 or fewer winners. To me, that honestly seems a little high because the odds of you getting that unlucky in 30 bottles of soda bought, seems like it would be lower than even 15% to me, but I think that's still within the realm of reason. I think it's certainly still within the realm of reason. One of the classes, 6 times we got 2 or fewer winners. I think it was 4 winners twice and 2 winners once. That's definitely high. You're not going to get, if you bought 30 bottles of soda, you're not going to get 2 or fewer winners, 30% of the time, which is basically a third of the time. That's way too high. But it seems within the realm of possibility to me. Number 12. Don't have to write anything for number 12. We're going to talk about it. Does it seem plausible that the company is telling the truth, but the class just got unlucky? In other words, do we have convincing evidence that sugar water is lying? Well, if 1 or 2 of my dots are off, then I'm off, but use the original dot plot you did. I believe we had 4 7s, 5 6s, 3 3s, 3 4s, 2 3s, 1 2, and 2 1s. 5 8 11 2. Yeah. So I believe this is correct. Okay. So looking at our dot plot, does it seem plausible the company is telling the truth in terms of their 1 out of 6 claim, 1 winner out of every 6? And the class just got unlucky. Or in other words, do we now have more convincing evidence that sugar water is lying? Well, thing we still have to remember is this. Again, even with 1 million bottles of soda, we've bought more than 30 now. We've bought 600, but that's still a very small percentage, right? But, we have a larger sample size than before. So if our average is closer to 1 out of 6, which again would be 5 bottles and 30 winners. That's really what we're looking for. We're looking for an average of 5. We took all those dots and divided them by 20. We were looking for an average of 5. So if it's close to that, that'd be enough evidence to me that the soda company is telling the truth. Okay. So if you add these up, 1, 2, 2 is 4, 3 is 7, 3 is 10, 4 is 14, 4 is 18, 4 is 22, 5 is 27, 5 is 32, 5 is 37. There's 5 sixes, 6 times 5 is 30. So we add that to 37 to get 67, 74, 81, 88, 95. So we got 95 total winners out of 600 bottles. But again, we're not looking for the number of winners out of total number. Well, take that back. We are looking for that, but if we divided 95 by, I was trying to figure out that, sorry. If we divided 95 by 600 bottles, that would give us a decimal. And we'd have to compare that decimal to what the decimal would be for 1 out of 6, which is 0.166666666 repeat. Okay. It's easier for us to use this if we take our 95 bottles, divide it by 20 trials, get that number and compare it to 5, if we got 5. Okay. So if you divided 95 by 20, we would get 4.75. So we're averaging now over our 20 trials, 4.75 winners. Okay. Which is obviously pretty close to our 5 that we're looking for. Again, I really want y'all to think about it. Make sure you understand. The odds the company says are 1 out of 6, right? But our experiment, we're buying 30 bottles at a time. Every time we run the experiment, every time we run the trial, we're buying 30 bottles at a time. So we need, if it's 1 out of 6, we need 5 winners every time we buy 30 bottles. So that's really what we're looking for here. So we got 4.75 winners on average out of the average for every 30 bottles that we bought, which is close enough to 5. That would tell me I think sugar water is telling the truth. All right. So last thing that y'all got to write. This is one y'all are going to have to kind of do on your own. Okay. Last thing you're going to do is one more kind of application activity in terms of this. It's not down here. Okay. It's the cereal box problem. Y'all see I have the link here. If you're in Canvas, it's the last link here, the cereal box problem. All you're doing is writing down the data that you get. Okay. That's all that we're doing here. So you're going to click on that link. It will take you to this tab. Okay. We'll quickly go read over the problem that we are presented. And I will tell y'all what to do. Okay. So we're still looking at 1 to 6. Suppose there's 1 of 6 prizes inside your favorite box of cereal. If you saw the page, it's actually going to be little plastic animals. So now we're not asking what are the odds that we pick one specific animal out of 6. Like we roll a dice and get on one specific number out of the 6. Now what we're trying to do is see if we buy boxes of cereal until we get all 6 prizes, how many boxes of cereal would we have to buy on average to get all 6 prizes? Okay. So if they're very collectible things, but you got to have a whole set, there's no way to know what animals in what box until you buy it. So you're going to have to buy the box, open it. If you actually eat that much cereal, eat that much cereal. If not, if you're just trying to get the toys, maybe donate the cereal somewhere else, if you were doing this in reality, right? But again, that might be impractical. If, we asked most of y'all in class when we actually talked about this, how many boxes you expect. Most of y'all said in the 20 to 25 range. So even if it is at the bottom of that range, $20, if you're averaging $5 a box per box cereal, you're blowing $100 right there, right? So is there a way that we could do this without actually having to buy the cereal? Well, we can go back to the dice. Since there's 6 prizes, each side of the dice represents one prize. And we could roll the dice until we've rolled each number at least one time. So that means we've gotten each prize at least one time. However, we have this simulator. It kind of does that instead and is a little more fun than just sitting there rolling more dice, okay? So you're going to go to the simulation. You're going to change the number of animal types to 6, all right? Before we actually do this, though, let me back up. I apologize. So our soda contest true, okay? Last thing you did, if you can see it, was 11 A, B, and C, the decimal, fraction, and percentage. Now, again, you're going to do another page break. The cereal box problem, write it down. I apologize for this handwriting here. I think I was showing it to somebody and was kind of writing upside down. But you're going to write the word boxes. I'll show it in a second. Boxes and average, AVG. Okay. Let me show it. I'll just write it here since it was flipped upside down. You're going to put the cereal box problem on your paper. You don't have to write the word simulation, but under that, you're going to put boxes. I would leave a second line underneath boxes just in case you need it. You'll see what I'm talking about in a second. And average. So what this boxes is saying is this. I'm going to click run simulation. When I do that, it's going to act like I'm buying boxes of cereal one at a time and pulling out the prizes. And the simulation is going to run until I have pulled all 6 prizes. So the first time I pull the 6th prize, the last one I'm looking for, the simulation is going to stop. So I'll click run simulation. I'm going to let it run. I'll scroll down in a second. 22. So it's saying I had to buy 22 boxes of cereal to get all 6 prizes. If we actually scroll down here and look, we actually went 4 out of our first 4. Alligator, elephant, tiger, lion. So we went 4 for 4. We only need the giraffe and the bird. Got another alligator, another lion. Then I got my giraffe. All right, so I bought 7 boxes, 5 animals. I just need a bird. Well, I got a whole bunch of giraffes. Giraffe, lion, giraffe, lion, giraffe. Alligator, tiger, giraffe. Tiger, lion. Finally got the bird on the 22nd box that I bought. So, beside boxes, you're going to put down 22. You're then going to click run simulation again. Now we only had to buy 14 boxes. Again, good start, 3 for 3. Tiger, bird, elephant. Bird, tiger, bird, bird. Got my giraffe for my 4 and my lion for my 5th back to back. So I only need the alligator. Got another tiger, a couple elephants, another lion, and then got my alligator in the 14th box. So you would put 14. And then you would do your 3rd trial and keep going. You need to do 20 total trials. Again, preferably I'll do 20 on your own. If you put the 22 and 14 I started with, you can do that. Do 18 more. It keeps track of it right here. So if you're writing your list of numbers and you lose track, this will tell you how many times you've done it. So you're going to have a list of 20 numbers. It's a long list. That's why I said you might need another line. After you have done your 20 trials, only after you've done your 20 trials, because some people are getting confused on this in class, whatever it says your average is what you're going to put down. So you're only putting one number for average, whatever your average is after you've done your 20 trials. That's what you're going to put down. So that's all you need to write for the cereal box problem. That's the last thing you need to write for the lesson. I will wrap up this real quick, though. So you run 20 trials, okay? Again, most of the classes I said were saying they would think between 20 and 25 boxes of cereal would be the amount that you would need. But if you actually calculate, and again, I've still had another opportunity to look this up before I record this video. I didn't, but they calculate the probability with this down here. It's something along the lines of there's 6 total prizes, and pulling any of the 6 are possible. So you just need, 1 pull to pull your first prize. Might need 2 pulls to pull your second prize. It's sounds like a clunky explanation because it is, but it's something along that idea. We would add all this together and we would get 14.7. So, round it up to 15, we would need to average buying 15 boxes of cereal to get all 6 prizes. All right. Again, that video took me a little longer than I wanted to. It took a little longer than the first one, but I've recorded it. Feel good about it. So there's the end of your first lesson. As I said, this isn't always how these videos are going to go going forward. Just trying to, had a lot of people, missing days here at the beginning of the year. Some people still not having laptops, people joining the class. I've told you everything you got to have on your worksheet to turn in. Okay. Again, really the only thing you had to do yourself was right there at the end to do your trials. I decided to do the dice roll simulations for you. So you had to do your own trials for the cereal box problem. That was pretty much it. If you're missing out, again, stuff that you're going to have to do on your own going forward is the stuff that everybody else did in class going forward. So, it's not like I sat there up on the board and did it for them and you're getting punished and after you on your own because you were out of class for whatever reason. So that's kind of my logic behind it. Anyway, so there's your first lesson. Make sure you get all your work recorded. Again, if you still just want to double check with me, make sure you got everything before you upload it. Send me a message on Remind. Say, hey, coach, can you check this real quick before I upload it? I'll check it for you, tell you if it looks good, if you're missing anything, and then you can go ahead and upload it to Canvas. All right. So that's our first lesson. I will see y'all in the next video online. And probably before that, I will see y'all in class.